do a char pointer, we have to do a malloc, right? We got to do a heap allocation. I'm pretty sure we got to do heap allocation. It's just inline on, and it's just allocated in line. And it's not like, it's not a very large data stack. Let's see if we can do that. And see if we can remember this. Char pointer. Here's a question. I want, it's a style pattern. It's a style guide. How do you define your pointer variables when you've got things like this? Char string, right? You can define a char string, and then you can say string equals malloc. I don't know. What happens if we do that? Can we do that? Is that going to work, or is that going to crash? It doesn't like it. Oh, do we need standard lib? Okay. Let's see, stdlib. All right, so we need standard lib for malloc. Calloc. Oh, right. There's a different types of mallocs, right? I'll post it in Discord under free resources. Just look at once you're ready. Data from IO. That's what that's going to do. So, right? Is that can take input from let's try this. Okay, let's try this. Let's try it. Let's try using the scanf function. I've not necessarily needed to use this before. All right, so one second. Let's actually comment these things out really quick. La 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 la, looks good. Okay, this build looks good. Okay, let's try scanf. So we'll do like this. Char string malloc. I think you can do like that, right? So try this. Allocate returns null. Oh, the calloc returns null if it's set to 0. Got it. Okay. Torva, yep, nice. Good to know. Good to know. It's not about doubt. You can write any simple, then try to find out assembly instructions. Any function will be, and it'll work. All right. We might have to investigate that a little bit more. All right. Write an implementation of calloc that performs the allocation by call to malloc. And set the memory to 0, right? Via memset. Your code should not have any vulnerabilities due to arithmetic overflow, and it should work correctly. Paste. Okay. Here we go. Okay. Delete. Okay. So we want to write our own calloc function. Have this, and then we're going to call memset is easy, I think. Maybe. All right. Let's just define it here. From where to start using the allocated. Yeah. So we should do malloc, right? We should do a malloc here. We need size. nmemb times size, maybe. The only problem is I don't know how it's going to work from a data type perspective. Is this Rust? What are we doing? Oh, Kyle, this is C. We're just doing C basics. And just kidding, Torva was like, hey, let's do something a little bit more advanced. I'm like, I was thinking of just doing strings and printing data. Now we're going to write our own calloc. Well, I don't know if we... See, the thing is, I think this function might already be defined, although we're going to find out. Let's see, can we build it and run it? Is there going to be a problem? Previous declaration. See, that's what I thought. So we'll call this Steven underscore calloc. Let's see if that works. All right, better. Then use a case to type if you want it. Yeah, we need to do a type conversion, I think, at some point. At some point, we got to do a type conversion. Okay, so we need to void pointer data equals malloc. Let's just delete this. All right, so is that how we do that? And then we do memset data, and is that it? Actually, I don't know. Return data. Now, obviously, this is not safe. Oh, int star equals. Yeah, if we've got a specific data type, do we have to do that? I can't remember. Or some such. Yeah, malloc. All right, so there's just some random data of a certain size, right? Of a certain type, the number, and then the size. Is that going to build? Okay, memset function. Scroll up here. Call to undeclared library. Oh, we need to import this. Oh, include header string. Okay, so we need this guy. Okay, maybe. Okay, all right, there we go. Making some ways. Memset expected expression. Oh, so we need to. It wants. How do we use memset? I thought it was just. Oh, let's read through this more. Return data. Void function should not return value. Oh. Do we do that? Or do we do like the address of? Something like that. Do we have to do something like void pointer? We'll figure this out. Should not return a value. Yeah, but I mean we want to return a pointer? A void pointer? Okay, there we go. Making progress. I don't know if that counts. Are we cheating now? Because we changed. Okay, so there's more to memset. So this is the definition of allocate is easy. It's just one straight up. And then memset is going to say what the data is. So do I say data? It already is a data. A void. Built-in destination. Okay, destination, args, and then the size. So we need one more thing. Destination. Seems good to me. Int C. What is this? All right, so I don't know what this. I need to look this up. We need to look this up. What is memset? What is memset? Memset. We're going to look this up really quick. All right, memset. All right. Okay, so we need a pointer to the starting of the address of the memory to block, which is this part right here. Right, so we got this part here, which is data. Easy. The second is the value to be set. Oh, 0. So do we just say 0? And then we say how much, the number of bytes to set. Okay, perfect. So memset, which essentially sets everything to 0, right? Is that what that does? I'm pretty sure. Okay. See if that is better now. Oh, hey, look at that. All right. Now we have to do a check, right? This could fail right here. This could fail, right? So if data, how do we check? How do we check if malloc fails? That's what I want to know. Check if malloc fails. All right, let's see. How do we do that? What comes back from malloc? Oh, it's just null. Then we do this. You should write your own calloc function. And I kind of did. So what we did right here is we wrote our own calloc function, called it Stephen calloc. And that should do the trick as far as I can tell. It'll set everything to 0, every single byte. And it will do that. So I do believe now we can do our own calloc here. We can do Stephen calloc like that. And that should work without probably issues. Oh, we need two. Is it 1010? Well. All right, well, that works. It works fine. So yes, the logic itself is right. Only thing that breaks is the overflow and when nem is 0. I forgot about user input. You bring up a really good bargain there. You bring up a good bargain. All right, so we got to validate user input. Okay. If nmemb is less than equal to 0, then we also return none. I guess can we return null? Can we just do that? Does that work? It does. Hey, that's good. All right. Made it a little bit better. I know I'm just like making stuff up. Me over here returning a void pointer to nothing, to 0, just so the compiler can work. When you just return null. Forget about this. Yes, use the logic. You're right. Okay, so sir, with due respect, are you doing? This is C. You got it. We're doing C. I know C is an old language now. You don't necessarily want to use C directly anymore now that we have things like Rust and other higher level languages. We're doing this just to revamp on some things. Also, Torva in chat in our Discord channel said, hey, we should see if we can do this fun exercise, which goes beyond the basics. I mean, it's kind of the basics. It really is. I mean, I'd say it's like, it's not, it's just a step up above it. I was thinking like, ooh, super basics. Like, let's validate user input. Then we do allocate memory based on size. And then we do, if allocation fails, otherwise set all memory. So this is a good way. So one of the things is with C, if you didn't know this, when you allocate memory, you're getting access to an address block of memory or a virtual table lookup of memory. However, the data that's already there, that's been manipulated, is still, I believe it's still filled with whatever it was, whatever the operating system left with it. They didn't change it. You have access to whatever it was before. So if you try to read or write to it, you're whatever. You're on your luck. You're on your own. So if you do memset, it clears it all out, which is another write to memory when you don't necessarily need to do that. It's fine if you do it. It's just, I think you just need to be aware that in certain situations, you might want to zero it out just from a safety perspective. You don't have to, though in some cases you might want to. You're just, we're doing a calc. Torva gave us this strategy, said, hey, check this out. Maybe it would be fun if we wrote our own calloc function. And we did. And so we did pretty good. Oh, they're about this syntax. Can this work? Is it supposed to be this? Is it missing something, Torva? So we got 2 minutes left. So Torva, if you're still here, was that wrong? Is that a typo? Will that work? I don't even know if that works in C. Let's see if that works. Let's try to build it. It builds. I don't know how. I don't know why. Torva, you can really do